When we think about the most iconic rifles of the 20th century, two names always stand out: the M16 and the AK-47. Both were created during a time of rapid technological change, when nations were pushing the boundaries of engineering, innovation, and military strategy. Yet despite being introduced around the same era, these two designs carried very different reputations. One became known for rugged reliability under harsh conditions. The other, although technologically advanced, gained early criticism for frequent malfunctions. Today, we are not discussing battles or conflicts. Instead, we're exploring engineering, design philosophy, and mechanical behavior. So the question we seek to answer is simple: why did the M16 encounter jamming issues while the AK-47 was praised for its reliability? To understand this, we need to go back to the origins of both designs.
The AK-47 and the M16 were born from two completely different mindsets. On one hand, the AK-47 was designed with a single priority: function even under the worst conditions possible. Its creator believed that a weapon must operate despite dirt, mud, humidity, or a lack of maintenance. In other words, make it simple, make it strong, make it reliable. On the other hand, the M16 represented a new generation of engineering: lightweight materials, advanced ballistics, and exceptional precision. Its philosophy focused on reducing weight, increasing accuracy, and using modern manufacturing techniques. These contrasting mindsets laid the foundation for everything that came later: how each rifle operated, how it reacted to its environment, and even how it was maintained.
Let's break down the core mechanical differences. The AK-47 uses a design with looser tolerances, meaning its internal parts have more room to move. This sounds inefficient, but in reality, it's one of the keys to its reliability. Dust, mud, and carbon buildup have space to escape, rather than clogging the mechanism. The M16, however, was engineered with tight and precise tolerances. This allowed for better accuracy and smoother cycling as long as the system stayed clean. But in harsh environments, tiny grains of sand or excessive carbon had nowhere to go. The result? Increased friction and the potential for malfunctions. In essence, one design embraced resilience, the other embraced precision. Neither is wrong. Each simply reflects a different purpose.
The AK-47's internal mechanism was intentionally designed to operate even when conditions were far from ideal. Its gas piston system generates strong momentum with every cycle. That power helps push debris out of the way, ensuring that the moving parts continue functioning. The bolt and carrier move along rails that are intentionally oversized. This gives impurities room to escape and prevents parts from sticking. And every component, from the spring tension to the chamber design, was built with durability in mind. This isn't about perfection, it's about consistency. A system that performs reliably, again and again, regardless of cleanliness or climate.
Another part of the story lies in the ammunition. The AK-47 fires a 7.62 by 39 mm cartridge, larger, heavier, and more forgiving. Its strong recoil impulse helps the mechanical system cycle reliably, even with debris present. The early M16 used a 5.56 by 45 mm cartridge. It was fast, lightweight, and accurate. But during its introduction,
The type of gunpowder used was changed from the original design specifications. This new powder generated more residue, leading to faster carbon accumulation. The result was not a flaw in the rifle itself, but rather a mismatch between design and implementation, an unintended consequence that affected reliability.
One often overlooked factor involves the early instructions given to soldiers. At first, the M16 was presented as a low-maintenance weapon. Some manuals even implied it was self-cleaning. Because of this misunderstanding, proper cleaning equipment was not initially distributed, and many users lacked training on how the system truly worked. This led to predictable problems. A precision-based system, operating in harsh environments without proper maintenance guidance, this combination naturally resulted in malfunctions. The AK-47, in contrast, was simple to take apart and clean. Its design made maintenance quick and intuitive.
Environment plays a major role in any mechanical system. Heat, humidity, dust, and sand can all interfere with moving parts. The AK-47, with its generous clearances and strong cycling force, was resilient in these conditions. The M16, however, required a cleaner operating environment. Sand or carbon deposits inside its tight clearances could disrupt the movement of the bolt or carrier. Again, this is not a weakness. This is simply the nature of precision engineering in adverse conditions. Different tools for different philosophies. It's important to clarify one thing. The issues experienced by the earliest M16 models were not permanent. Once the proper ammunition powder was restored, once cleaning kits were issued, and once training improved, the rifle's performance changed dramatically. Later versions, like the M16A1 and the M4, implemented numerous upgrades, revised chamber design, chrome-lined components, improved materials, clearer maintenance instructions, and better reliability under adverse conditions. Modern variants of the M16 family no longer suffer from the early problems that shaped its reputation. This evolution reminds us that engineering is never static. Designs improve, adapt, and evolve over time.
So why did the AK-47 dominate in reliability while the early M16 encountered difficulty? The answer lies not in superiority, but in philosophy. The AK-47 was crafted to work under nearly any circumstance, accepting a loss of precision in exchange for absolute durability. The M16 was built around accuracy, modern materials, and innovation, accepting that such precision required maintenance and proper conditions. Both designs succeeded, each in its own way. Each achieved exactly what its engineers intended, and both became symbols of their technological eras. In the end, this story isn't about which one is better. It's about how engineering choices shape real-world performance. Different goals lead to different solutions, and both can be effective when used as designed. Narrator, closing. Thank you for joining this documentary-style exploration of two legendary designs. Their differences teach us not about conflict, but about creativity, engineering, and the diverse ways humans solve problems.
The M16 introduced groundbreaking technology for its time. It used lightweight materials like aluminum and plastic,
making it significantly lighter than earlier designs. Its direct gas impingement system reduced moving mass, improving accuracy and controllability. But this system also had a drawback. Hot gases, along with carbon residue, were vented directly into the internal mechanism. Over time, this buildup created friction, slowed cycling, and increased the chance of a malfunction if not cleaned regularly. Precision always comes at a cost. The M16 rewarded good maintenance with excellent performance, but punished neglect more quickly than the AK-47.